M has unit of mass, yeah, and that's all I tell you? Or do I tell you anything else?
T is time.
And T is time, seconds, okay. So I give you a length, a mass, and a time. Yeah, okay, so that's okay. So the first question is, what's the unit of
Dimension unit of U equals to D upon T.
Okay, what's the unit of U? Was it? And that's equal to D over T. Now, well, that should be okay for the first one. What's the unit for D? It's meters and so yeah. So for the first part here, 1A, you have U equals D over T. So the dimension of U will be length over time, which is length per time, and the unit is meters per second. So that should be. I would hope you got the first one. No, it's the second one. V equals, is it?
V equals to U plus AT.
And what do I want?
V. Want unit of V.
Okay, that's okay. So the unit for V, or the dimension for V, must be the same as U plus AT. But because they're being added together, each one must be the same. So I don't know what this one is, but I do know what this one is, because I did it previously. So again, the answer is meters per second, length per time. Yeah. So what do we think about that? Is that okay?
Yeah. But for acceleration A, it should be meter per second square.
Yes. Is that the next one? Is A, is it?
Yeah.
So you can rearrange this as A equals V minus U over T. So the dimension of A is the same as the dimension of V minus U over T, which will be the same as the dimension of V minus U over the dimension of T. Because these are added together, they must have the same dimension, so I don't really care about V minus U. I just need to know one of them. So I'll just choose the V because it's the first one. Now we already have the V from earlier. It was meters per second, and the time is also per second. So it's meters per second squared, and the dimension would be length per time squared. Yeah. It's not crazy. It's not crazy difficult. Okay, and is there a D part? Oh, the F equals MA, isn't it?
Yeah.
Okay, well that's okay because the dimension for F will be the dimension of M multiplied dimension of A. We know what the M is. Its unit is kilograms. And the A we have is meters per second squared. The dimension would be mass length per time squared as a dimension. I like this topic. It's kind of interesting because this is a topic which I feel most high school teachers kind of skip over or go through quickly. Do you know what I mean? Like, I'm sure, well maybe not, but I'm sure for all of you this is kind of new. Yeah. But I think it's important, and it makes your life easier later to understand how you can find the units, the dimension. Did you do this before? Do you think?
I think so.
You're not?
So.
Okay, yeah. Not 100% sure.
I'm not a great student.
Yeah. Well, that's last year. This year is different. Yeah. Okay, and the last one now is with the F equals G one, is it? Yeah. Now this one caused a lot of talk last time. There's people talking about the G as a constant and all of this stuff. So, did you get an answer in the end?
Yes.
Yes, okay. So what we should do first, I am going to rearrange this. I'm going to say G equals F r squared over m1, m2. Just bring this up and bring these down. Yeah, cross multiply, yeah. Now, that means the dimension for G is the dimension of this. And the great thing is, we know each of these units. So, the F, we just did it. It was
meter per second squared.
kilogram meters per second squared. The R is distance. Oh, sorry, it wasn't R, I think it was a D.
Yeah.
The D is distance, so that D would be m squared. And here is a kilogram, and here, kilogram. So on the top you have kilogram, meter cubed, S minus 2, and on the bottom you have kilogram and kilogram. Now, something cancels.
Yes.
Yeah, you can make it a square, but
You can't
you can cancel those. Yeah. So you have meter cubed, second minus 2, kilogram minus 1. This is the unit.
Why is this why you not cancel the third one? The third is wrong.
Which, this one?
Yes.
You cancelled 1 with 1.
Yeah. Okay.
Yeah. So what would be the dimension? Well, the dimension is length cubed per time squared per mass. That would be the dimension.
One question.
Yeah.
If I write in M first and L.
Yeah, the order is
Yeah.
completely up to you.
Okay.
Yeah.
That's fine.
I don't know what's the usual order.
But
At the very least, I think,
it's MLD.
I have a feeling that if you were to look at this in a book, I think the usual thing is to put the time at the end.
Yes.
Maybe. That's what you did, yeah.
We do in our country, it's M, then L, then T.
Yeah, I think we'll stick with that. So we'll go with this.
Yeah, that's fine.
Yeah. But no, it doesn't actually matter too much. Yeah. Okay, this is number 1. That's okay? Okay enough. Yeah. What's number 2? Oh, that's the paper one, isn't it? Number 2? Yeah. So can I scroll down?
Yes.
Yeah. Okay, number 2. So, I have
Area
50.
No, you have area of 62370 millimeter square.
62370.
70 millimeter square.
And I want it in
And meter square and
centimeter squared. Okay, so this is 62370, 0.01 meter, because that's milli squared. That will be 62370 times 0.0001 meters squared. 1, 2, 3, 4.
So it
No.
will be 3.7.
Yeah, I'm doing something wrong here.
Yeah, it's 0.01, it's not 0.01, it's 0.001.
Oh, so sorry. Yeah, there's an extra 0 here. Thank you. Yeah. So that means there's an extra 2 zeros here. That's much better. So that's 6 zeros, isn't it?
It's
1, 2,
0.9.
3, 4. Yeah, 6. 1, 2, 3, 4, 5, 6. So 0.062. We'll just say 624 if we do 3
Yeah,
meters squared.
that's fine.
That's it. Yeah. You can just use your calculator. You're less likely to make a mistake. Okay, so the next, that's okay. The next one is a little tricky. We want centimeters squared.
Yes.
Yeah? This is part
B.
A and this is part B. Okay. Right. I'll use my previous answer to help a little
Yes.
bit. Yeah.
And
Okay, so 0.0624. Now, what you have here is meter squared. But what do you want?
we want centimeter square.
Centimeter squared. So you must have a centi squared here as well, because then these two can make centimetre squared. But I can't just put a centi squared here. I have to balance it by doing what?
But dividing by 1 upon
Yeah, dividing by centi squared.
Yeah.
So it's still the same. Now I've made the centimetre squared at the back, but the price I pay, like the price I pay to do this, is I have to put this underneath to keep it balanced. For example, if I had 4 over 2, what does that equal?
1,
2. So I can't just say 4 over 2. That's a different number, isn't it? So if I multiply the top by 10, I have to do the bottom by 10 as well. So this is the same idea. To keep it balanced, I put the centi squared on the bottom. Yeah? Now, how big is centi?
1 upon 10 minus
0.01 squared meter. Oh, actually, but no, sorry. I'll leave that as centimeter squared, the two of them together. This one is 0.01 squared. So this will be 0.0624 over 0.0001 centimeter squared. 1, 2, 3, 4, 624 centimeters squared is the answer.
Yeah.
Now that one was tricky, but this is what you will need to do in the exam, because in the exam sometimes they might give you the information like this, and then you have to work backwards to meter squared, like this. So you do get these in the exam, and if you didn't get that, you should write it down. I don't know if you did get it. Did you get it?
No.
Yeah. Andy?
Yeah.
Did you get it?
I got it.
Are you sure?
Yeah.
Should I believe you? What about over here, you three? Did you get this, or was it tricky? No. Yeah. What about the first part?
Yeah, I think it.
The A part, yeah. Yeah. I think there's one question left, is there? So are you doing your homework at home, or in the library, or what is the... At home? It's not too noisy?
No.
No? Are you in a homestay?
Yeah.
I do.
You're on campus, no problem for you. What about you guys? You're in a homestay?
Yeah.
By yourself, or?
I have one.
Oh, that's okay, I suppose, yeah.
My parents.
Oh, so they'll be quiet while you study, yes. And for you?
I'm with the host having 3 more students. And
Not too noisy with 3 more students?
They're friendly. They're good.
Okay, alright. Alright, next one. Yeah. Okay. Number 3, let me see, I already had Andy reading it. Yeah, maybe you can read it, please.
The mass of a hydrogen atom is roughly 1.67 multiplied by 10 to the power
Minus,
27.
that sounds about right, kilograms.
Kilogram, yeah.
Okay,
Consider-
this is, what did you say, hydrogen? Is that a hydrogen
Yeah.
atom? Yeah. Okay, next, yeah?
Consider the hydrogen atom as small as a sphere
Yes.
of radius 5.29 multiplied by 10 to the power minus 11 meters.
Great.
What is the density of hydrogen in...
Great, okay, great. Got that, yeah. Is that the only part? There's only one part?
No, there's a-
Oh, what's the density in grams?
In grams and
Yeah, okay.
minus 2.
Right, well, we know the formula for density. It's mass over volume. And I give you the formula for volume of a sphere.
Yeah.
Yeah.
4.3 pi r cubed.
Yeah. The mass is 1.67 times 10 to the minus 27. And the 4 over 3 pi, and this is cubed, 5.29 times 10 to the minus 11. Now, I don't have a calculator, I keep forgetting it. Can you use your super graphing calculator? You think, are you sure? 2?
Yes, 2693.54.
So we'll just say 4
Yeah, that's fine.
kilograms per meter cubed. Now, we'll have a double check with
Yeah.
that.
Okay.
But I think that's right. Which calculator do you have, Andy? The 991?
I don't know.
No, it's okay. Okay, can we confirm that answer? Confirm or deny?
Yeah.
Confirm or deny? Do you have it? You don't have a calculator yet, yes?
I do have.
Yes?
Yeah.
Okay,
Fine. Six.
we have it, yeah? Great.
Fine.
Right, now the B part is, again, a little tricky. We want to make it centimeters, grams per centimetre cubed, wasn't it?
Yeah.
Now the first thing to do is kilo. We know the value of kilo. What is it? 1,000. So I'll just change that into 1,000 and I'll just write as grams over metre cubed. So we are happy with this. This is what we want. We're not happy with this. What do we want here? Centimeters cubed.
Yeah.
So I need a centi cubed here. Yeah, on both. Yeah, and here I'll need to have a centi cubed as well, for the same reason of keeping it balanced. So on the top we have 2694 times 1,000 times 0.01 cubed grams per centimetre cubed. So that would be 2694 times 1,000 times 0.000001 grams per centimetre cubed. Okay, now, hang on. Let me think. There are, I think, this is 2.69 grams per centimetre cubed.
For converting into centimeter cube,
Yeah.
so we want divide it by 1,000 because it's in -3. We'll divide it by 1,000.
Which one now?
You have multiplied it by 1,000.
Oh no, that 1,000 here, that's coming from the fact there's a kilo. The
Yeah.
kilo is 1,000. So I replace the kilo with 1,000. Because its value is 1,000.
That's fine.
Okay.
But for going from kilogram to say gram, it will be multiplied by 1/10 minus 10(3).
Yeah, 10.3, yeah, that's 10.3 there, it is, 1,000.
No, it's
No?
not
Show me what you mean. Where? Here?
I've got the answer here. Now I've put the same value, and now I have to convert it in gram centimeter cube. I have done this one. So, is it right or wrong?
I think not right, because the kilo is
Yeah.
10.3, so the 10.3 should be on the top.
Oh, but kilogram is with meter, isn't it? Or it's different?
Yeah, you see this, I think this is the thing, high school teachers don't do a great job of explaining this, and I think you have some ideas in your head which I'm trying to pull away, the best way to think about, I had a student as well last year say the same thing, like, well, kilo goes with meter, don't think like this. Instead, what you should think about is like the K has a number value, its value is 1,000.
Yeah. So the K goes with the G, and if there is a C, it goes with the N. Okay.
I know what you're thinking now, yeah. No, don't think about the K going with the G. Think about the K multiplying the G, multiplying the N.
Yeah.
So I know you think the K is on the G,
Yeah.
but it's kind of like it's not, it's just multiplying.
Yeah.
Now here, though, you're right, the C is on the N, because when we write CM with a cube, it means the two of them together. And this is because really, maybe we should put brackets here.
Yeah.
Yeah, I know it's a bit confusing.
So this step is fine.
No, this needs to be 10 to the 3 on the top.
And what about this?
I don't know where you got this from.
This is, look, one is for the kg and one is for the centimeter. So
But where did this one come from, you know what I mean? Like, what was this on the previous line?
for the C.
Oh,
okay,
yeah.
then it should be -6. Maybe.
Yeah, because that's what I'm getting here. You see, this is a
Yeah,
minus 6
minus
then.
six, yeah, that's fine.
Yeah.
I got it.
Try to write it the way I'm doing it. I think
Yeah.
it'd be
Yeah, fine.
more helpful. Okay. Was that the last question for this?
Yes.
Yeah. Okay, so we'll go to the next lesson then.
Should I?
You can get it from the video because